Hey guys, today we are going to be learning about Unit 1, Section 4, which is on angles and their measures. So we did talk about angles the very first lesson, but we're going to go more in depth with that. So just as a quick reminder, an angle has two different rays that have the same initial point, which we call the vertex. So in this example here, we have sides AC, ray AC, and ray AB. Notice that they both share point A, that is the vertex. So the vertex is the most important angle. And there's three different ways that we can name an angle. So you can name it as angle A by the single vertex, angle CAB, so we go from C to A to B, or we can go in the reverse order where it's B, A, C. A lot of times we are going to use 3 points to name angles. Kind of depends on the figure that we're looking at, and we'll practice this throughout the year. But the vertex angle always has to be in the middle. Okay, now we have different types of angles, and a lot of these I'm sure you've seen before. Acute, remember, is between 0 and 90. Right is exactly 90 degrees. Obtuse is between 90 and 180. And then a straight angle measures exactly 180. And then complementary and supplementary. These are two terms that we're going to want to get down, especially for Chapter 2. But complementary means two angles whose sum is 90 degrees. So let me just kind of draw a picture here. Let's say that we got angle, this is C, we got, actually let's not call that C. Let's say that we have A, B, C, and here's D. So angle ADB, which is this angle right here, combined with the angle right next to it, BDC, say that angle right there, together, those form a right angle. So we say those angles are complementary because together their angle sums add up to 90. So maybe this one is 50 and this one is 40 degrees, whatever adds up to 90 between the two. Supplementary is the same idea. So say we have two lines, two angles. We got this one right here, and then we got this bigger angle right here. Together, their measures form a straight line making 180 degrees. So maybe this one is 130 and this one's 50 degrees. You add those together, you get exactly 180, so they're supplementary. Congruent angles are two angles that have the same measure. You can say that the measure of an angle A is equal to the measure of an angle B. Or you can say angle A is congruent to angle B. So congruent angles always have the same measure. And remember, this is that congruent symbol. It's the equal sign with the squiggle over top. So when we're talking about angles being congruent, we know that their measures are going to be equal to each other. Okay? And so if this one up here is, let's say this is 34 degrees, we know that angle A is congruent to angle B, therefore their measures are the same. Okay, this is just an image of how you would use a protractor. I'm sure that a lot of you have already used a protractor. It's going to look a little different this year since we can't really share objects, but we will make the most of it. So we can measure an angle using a protractor, align one of the rays with 0 degrees, and count up to the number of degrees. Now notice that measure AOB. Now this looks like it's bigger than 180 degrees, but there's like two different options that we would pick for this angle. Because if you look at the top, so here is 60 and 120. Well, this angle is obviously larger than 90 degrees, so it would make sense that we would take it in relevance to 120 degrees. This one isn't exactly 120, it's actually 117, but we're not going to look at the 60 degrees as our reference. We're going to look at the 120 because it's greater than 90. I have a video that I'll probably share later on about how to properly use a protractor, but for right now, we're not going to worry about it too much. The angle addition postulate. If P is in the interior of angle RST, then the measure of angle RST is equal to the sum of the measure of RSP and PST. All right, that's a lot to take in, but basically what it's saying is, so we have this big angle here. Let me just get a different color. So we have RST. If P is in the interior, so here's P, so it's inside of that big angle, then RST, the big angle, is equal to this RSP, this small angle, plus this other small angle added together. Just like the segment addition postulate, we can add up the two smaller pieces, and together they're going to form the big angle. So down here, for example 1, it says, given that the measure of angle LKN, so that's the big angle, LKN, find the measures of LKM and MKN. So we know that these two angles together are going to form 145 degrees. So what we can say is LKM, measure of LKM, plus the measure of angle MKN is equal to the 145 degrees, because that's what the total LKN is. So now we're just going to substitute out what the smaller angles equal, and right now we know that this one is 2x plus 10, and then MKN is equal to 4x minus 3, and together they equal 145. So we just took these values right here for the angle measures, and we substituted those in. Now we're just going to add up like terms and solve for x. So on the left side, 2x and 4x come together to make 6x. 10 and minus 3 come together to make plus 7, equal to 145. We're going to subtract 7 on both sides. 6x equals 138. And then we're going to divide by 6. And x is going to equal 23. So now that's not the final answer because it wants to find the total measure. We just figured out what x is. This is something you'll have to get used to in geometry, is a lot of the times we're just going to solve for x and then plug it back in. So now that we know that x is 23, I'm going to plug that in up here. So now it becomes 2 times 23 plus 10. Which is going to be 2 times 23 is 46, plus 10 more is 56 degrees. And then this one here, I'm going to substitute 23 in place of x. 4 times 23, is going to be 92. Subtract 3, we get 89 degrees. So here's our two answers, and off to the side, I'm just going to write the measure of angle LKM equals 56 degrees, and the measure of angle MKN equals 89 degrees. I apologize, there's not a ton of room to write, but just do the best that you can. And the last part of this is an angle bisector is another new term. So what bisect means is to cut in half. Bi means two, so basically it's an angle that is going to cut another angle into two congruent parts. So an angle bisector is a ray that divides an angle into two angles that are congruent to each other. So BD, which is the ray going directly through the middle of that angle, cuts it into ABD and DBC. And we know that those are congruent to each other since it bisects. Okay, so here it just tells us that ray BD bisects angle ABC. Okay, so this whole angle gets cut in half by this ray BD. So what that tells us is it cuts it into two congruent parts, and if two angles are congruent to each other, remember that they are equal. So what we're going to do is just set 5x minus 11 equal to 4x plus 1, since they're congruent angles, and then we can just solve. So subtract 4x, x minus 11 equals positive 1, add 11 to both sides, x equals 12. Okay? Now that's nice. X equals 12 is not the final answer. Remember, we got to plug it back in because we're trying to find the measure of angle ABC, which is the whole thing. So if I plug 12 in for the x in the top part, 5 times 12 gives me 60, minus 11 gives me 49 degrees. And if ABD is 49 degrees, this one's also 49 degrees. And if you plug in 12, you'll see that it also works there. So 49 plus 49 is going to give us the measure of angle ABC, because it's the two small angles added together. So the measure of angle ABC is 98 degrees once we add those together. All right, and that is it for section 4 notes. Let me know if you have any questions, and make sure to do